Okay, so we have a new digital interactive notebook. So we are talking about properties of linear functions. So as you saw on your unit divider, it's mainly about slope and about graphing and writing linear equations. So just a couple of reminders. If you missed class, you need to watch the video so you can get your notes. Or you can get the notes from a friend. Just be aware if you're just copying the notes, you're not getting my lesson and me teaching if you are just copying down the notes without listening to the video. Shortcuts again, Control C for copy. That's the one that I do the most. Control C and Control Paste, Control V. So keep those handy. Here is our reference material, and then calculator cheat sheet, which it's on Google Classroom. Google Slides toolbar, different ways to customize. So you can go to there. And you can also go to Edit Master to change the font. I saw in some of y'all's from Unit 2, the font was really cool. I don't know what it was, but it looked like actual handwriting some of y'all used. Something I want to remind you of, that at the end of the unit, this end of unit reflection is something I read and I'm counting. I am reading it and deciding, are you really thinking about what you learned this unit? Are you really reflecting on what you were clueless about before and what you now know? Are you really wondering about something? Are these important words that we learned within the unit? This is something that I want you to do to reflect on your learning from the unit. So if you leave it blank, it's counted off. If you don't take it serious, then you're counted off as well. Okay, so we are on linear functions. So linear functions, we want the definition first. So we need to insert a text box. So what definition did y'all use for linear functions?
A function in which the graph of the solutions form a line.
A graph of the solution forms a line. Let me make this bigger. Okay, let's talk about the characteristics of a linear function. So one of them that we wrote in the previous forms a line. What else? In order to form a line, what do we know about the point from one point to the next?
Continuous.
Continuous. What would that be? Just a continuous relationship? Or continuous when points are connected? Okay. What else? What about the slope or rate of change? Constant rate of change. When we graph it or we write the equation of the graph, you can have it in two forms. You can have it as y equals mx plus b. I'm going to put equation written as y equals mx plus b, or the standard form, ax plus by equals c. And the last thing is the variable x has an exponent of 1. Yes. Can you see it? It kind of moves down whenever I make it bigger. Okay, some examples of a linear function. Let's go ahead and just write an equation. So y equals 3x plus 5. It's an example. Let me see if we can find an image from the web. Linear function. Go to image, search. Search the web for an image, linear function, and then I'm going to bring one of these over here as my example. You could put any one of these on there. Here's another one. I don't like that one as much. So it can go positive, negative. It could be just a straight line. Let's see. Did y'all insert something? Okay, good. And then the non-example would be if we have an exponent of 2. So y equals x. Is it command, comma? Or command period? Plus 1 or something? Control. Oh, mine's command because I'm an Apple. Sorry. Control period to get exponent.
Wait. Control. Oh, wait. Yeah. Oh, wait.
I don't really even like that one. I'm just going to keep this one right here. That's a good example. Okay, so then how could we do a non-example? Let's go to insert, image, search the web. Non-linear function. Oh, here we go. It's like a squiggly. Did y'all know that we could have squigglies in a graph?
Yeah.
Oh, you found one that moves? Okay, so tomorrow we are going to finish some of these slides so we can move on to graphing on the next day. All right, so we're done for today.